So Unit 3, Lesson 3, Inverse of Quadratics. Recall that there are a couple of ways of looking at what an inverse is. So as you can tell on the right, I try to write some side notes so that you can refer to it later, so that you can go back to some previous topics. So inverse is to undo an operation, and a simple way to think about it is to switch x and y, the input and the output. And so for question 1, it says find the equations for each of the following. So I'm going to try to identify some key characteristics. So first off, it's a parabola, it's a quadratic. Noticing that there is a vertex that I can tell, and the x-intercepts as well. So the vertex is 4, comma, negative 4. I'm noticing that there is a step pattern to it, 1, 3. I can also tell what the x-intercepts are, so you could write it as in factored form or in vertex form. So see my notes on the side on what the step pattern is and where it comes from, but basically from y equals x squared. And so because it's consistent with the step pattern 1, 3, 5, I could say that the a is equal to 1. Right? So let's write down the equation for the vertex form of the quadratic. So y equals a bracket x minus h squared plus k. I'm going to plug in some values that I know. So y is equal to 1, x minus 4 bracket squared minus 4. And out of habit, I'm going to write f at x. So in terms of function notation, x minus 4 squared minus 4. So that would be my equation for question 1a. For question 1b, what kind of function is it? What would the parent function look like? So recall that from the function unit. And you should notice that the parent function is the y equals square root of x. So it's good to know what the parent function looks like. And so it's going to be 0 and then 0, 0, 1, 1. And at 4, the square root of 4 is 2. So the parent function is y equals square root x. Okay, so the equation for the transform function of a square root function is g at x at a bracket, square root of k x minus d close bracket plus c. I need to figure out what my a, k, d, and c is. So it says in the square, for square roots, consider if there are any any reflections that would make the k negative. Then use k equals 1 or k equals negative 1 and solve for a using a point. Okay, so k is, one way to look at it is like the reflection along the y-axis. And I noticed that there is no reflection along the y-axis. Okay, so on the side, I'm going to leave some ways that you can find the a value. There are 2 ways. So one way is noticing that for the parent function, a value is equal to 1. Whereas for the transform function, I'm noticing that the a is equal to negative 2 because there's a reflection along the x-axis and the value that it jumps by is 2. So that would be a quick way of figuring out your a value, or you can use method 2, which is to figure out what the k value is, and k value would equal to 1 in this case because there's no reflection along the y-axis. And I plugged in a coordinate other than negative 3 comma negative 1 because otherwise I'll have like the a's cancel out and I wouldn't be able to solve for what a is. So I just plugged in negative 2 comma negative 3 on the side, and I also got a equals negative 2 that way. So either way, you're finding your a equals negative 2. And so I have y equals -2. We said k is equal to 1. And then, all right, so what does my shift look like? My horizontal and vertical shift. So I noticed that I have moved left 3 and down 1. So I'm going to write x minus, I went left 3. So I'm actually going to write, well, that means that d is equal to -3. And so I'm going to actually have a +3 when I plug in, because a negative and a negative makes a positive. And I went down 3, down 1, and so have -1. So C is equal to -1. So that is my equation for part B. And so the A equals -2, that you can find by the step. And I'm finding my 3 and my -1 by what? The shifts. Okay, so I went left 3, down 1. Okay. Find the equation for the inverse functions. All right, the inverse functions. So I have my original, the parabola. All right, so over here, I have the steps to find the inverse. So I'm going to replace the f of x as y. I have y equals x minus 4 squared minus 4. So my step says switch x and y. So x is equal to y minus 4 squared minus 4. My step says I need to get y by itself. So I'm going to move over that, -4. It becomes +4. So I have x plus 4 equals bracket y minus 4 squared. I want to get my y by itself. That means I need to square root both sides. When you do that, remember you get a positive and negative version when you take the square root. So I have plus minus square root of x plus 4 equals y minus 4. Almost there. I need to get y by itself, so I'm going to add 4 to both sides. And I will get the y by itself. Okay. So that cancels those out. Remember, my 4's don't cancel on the left, so I have y equals, I have 4 plus minus square root of x plus 4. Am I done? I'm not done. I need to state that the inverse function, and remember how it says function? A lot of people are making the mistake of just leaving it like this, or writing f inverse x, but not separating the positive and negative part. In order to be a function, it needs to pass the vertical line test. If you leave it like that, it does not pass the vertical line test. Because remember, this quadratic, this original function, when it is put into the inverse form, it's going to look like this as a rough sketch, which does not pass the vertical line test. Okay, so we'll do a more exact sketch later. So I have f at x, f inverse at x is equal to 4 plus square root of x plus 4, or f inverse of x equals 4 minus square root of x plus 4. Okay. Okay, to keep it a little organized, I'm going to highlight this one in green and then the other one in blue. Okay, finding the inverse of the second equation. Okay, so I have, I'm going to follow the same steps as the ones on the right. I'm going to switch the y and x. So x is equal to -2 square root of y plus 3 minus 1. I want to get y by itself, so I'm going to add 1, add 1 to both sides. So x plus 1 equals -2 square root of y plus 3. I want to get my y by itself, so I'm going to do division by -2 on both sides. So I really have, when you're dividing by -2, you're really multiplying it by -1/2. So I'm going to write it as -1/2 bracket x plus 1. Notice I'm putting this in brackets. Equals, where this would have canceled out intentionally. I have square root of y plus 3. I am going to I want to get the y by itself. So how do you do that? I need to square both sides by 2. So I have, well, -1/2 squared is 1/4 bracket x plus 1 squared. That remains squared. So when you take the square of a square root, you get rid of those and you get y plus 3. Want to get y by itself, and you're going to subtract by 3 on both sides. So y is equal to 1/4 bracket x plus 1 bracket squared minus 3. We're almost done, but we just need to write it as in function notation. So previously we named it g at x. So we're going to say g inverse x is equal to 1/4 bracket x plus 1 squared minus 3. No need to put it apart for this one. Next, we're going to try graphing it. So I need to start graphing my inverse. So easiest way is to remember to switch the x and y. So instead of having 4 comma -4, I'm going to have -4 comma 4. Okay, and then I have 5 comma -3. So instead of 5 comma -3, I'll have -3 comma 5. Okay, -3 comma 3. Instead, I'm going to have 3 comma -3. Instead of that, I'm going to have -3 comma 3. Okay, 6 comma 0. Instead of that, I'm going to have 0 comma 6 and 0 comma 2. Connect. So this is my F inverse. I'm going to use a highlighted to indicate which one is which. So 4 plus square root x was 4 should be the one on top. And the 4 minus square root x plus 4 should be the one on the bottom, based on if there is a reflection along the x-axis or not. Alright, so those are it for part A. So for part B, let's draw the inverse of the red graph. Okay, so same idea. So have -3 comma -1 as my coordinate. So reverse that. So I have -1 comma -3. So right here. Second, so I have -2 comma -3. So instead of that, I have -3 comma -2. So basically, what's going on is this matches up with this. This matches up with this. All right, and remember that part of having an inverse is that there's a reflection along y equals x, which is approximately here. Alright, so here, let's continue. There's a coordinate I see right here. Oops. So that's 1 comma negative 5. So I am going to have another coordinate at negative 5 comma 1. Alright, so I'm going to connect the dots. Okay, and this one's going to extend. And that is my inverse. So this is my G inverse. Okay. Notice that there's a reflection along the y equals x for the inverse. Okay, so question 3. What will be the domain and range of the inverse functions? So notice that they use the wording functions. So when given that that terminology, so what you're going to do is there are two inverse functions to this. So you're going to pick either of the green or blue inverse function and find the domain and range of it. So in this case, I'm going to pick the green one. And so because it says function, I'm going to pick one and state the domain and range. And I'm going to write the domain as, well, D, and you're always going to write the subscript. So D of F inverse equals, so that way we know what you're finding the domain of. Domain of F, the domain of G, domain of G inverse. So let's take a look at the green graph. So domain of F inverse. So if you notice that all of the x values are what? All the x values are larger and equal to negative 4. So we're going to write that. So x elements are real such that x is larger and equal to negative 4. So range of F inverse. So looking at the green again, notice that all y values are 4 and higher. So we're going to write y elements are real such that y is larger and equal to 4. So the reason I circle the word function is because if, let's say, you have a different question, and if the question says, and if the question does not specify, find the domain and range of inverse function, and that being the key word, and if they just say find the domain and range of the inverse, then you might be able to write then range of inverse is R F at inverse. Well, let's take a look. So what that means is you're looking at the range of the F inverse and you're really looking at the range of the whole thing. You're looking at the green and blue parts of it. And if you look at it that way, then Y will, what? Y is going to exist everywhere. And so Y elements of reals in that case. So note the different ways that the question can be presented. For question 4, I'm going to use a highlighter to indicate what graph I'm looking at. I am looking at this orange graph and finding the domain of that. So I want to find the domain of G inverse. So if you look at the orange graph, notice that all x values are less than equal to negative 1. So x elements are real such that x is less than equal to negative 1. Whereas the range of G inverse is equal to, well, it's always larger and equal to negative 3. Y elements are real such that y is larger and equal to negative 3. Question 5. The cost function in thousands of dollars for x thousands of items sold as C at x is equal to 0.75x squared minus 1.5x. Question A. What is the range of this function on the domain of 0 to 10? So you are given the standard form of this equation. And why do you think I have this completing the square on this side? Well, it's because if I have it in standard form, I can't really do a sketch of it easily. I need to turn it into factored form or vertex form, and preferably vertex form, because it's going to be the easiest to sketch it that way. So that's what I'm going to do. First thing, I'm going to complete the square. And you can refer to the site, the notes on the side, which I will upload with the notes. So equals. So first step, it says take a out between ax squared plus bx, so 0.75. So you have x squared minus, well, what's 1.5 divided by 0.75? Well, it's equal to 2, so minus 2x. That's the first step. As a side note, notice that the c value, or the y-intercept, is 0. Just going to leave that on the side. Second step, it says to do the b over 2 bracket squared step as the rough work. B over 2 squared, which is negative 2 over 2 squared, which is equal to negative 1 squared, which is equal to 1. Remember, this part's going to help us later on when we do our factoring. All right, third step, we're going to add that value, the 1, the b over 2 bracket squared value. So we have c at x is equal to 0.75 x squared minus 2x, and we're going to add that inside the brackets, plus 1 minus 1. So we're not really actually changing anything when we do that. Next, I'm going to have the fourth step, which is to take the negative b over 2 squared outside the bracket and bring it to the outside, so I can have a trinomial inside. So 0.75 times x squared minus 2x plus 1. Well, you gotta make sure that you multiply that negative 1 by the a value, which is 0.75. And so negative 1 times 0.75 is equal to negative 0.75. Are we done? No, we need to factor this part. And remember, I said the yellow highlight's going to help us, because negative 1 times negative 1 is equal to positive 1. Meanwhile, negative 1 and negative 1 adds to the middle value, the b value of negative 2. That means that is the factor. So c at x is equal to 0.75 bracket x minus 1 squared minus 0.75. And so with the yellow highlight, I'm going to highlight this. Meanwhile, this is the optimal value. So we have, as a side note, vertex is equal to 1, okay, because we don't take that negative with it, because that's already within the vertex form, and negative 0.75. Okay, so drawing my sketch, I have, okay, so I know that the y-intercept is 0, okay. I know that the vertex is 1, comma, negative 0.75, and this is a graph going up or down. Well, a value is positive, therefore the graph is going up. And because my distance is 1 this way, that means symmetrically I'm going to have my other coordinate this way at 2. What I mean is, if from here to here is 1, from here to here should be 1, because a parabola is symmetrical. Meanwhile, remember that this graph is in terms of x, which is the number of items, and c at x, which is the cost. Are we going to ever have negative number of items? No, and that's not going to make sense. So I'm going to cross that off. And somewhere along, I will have hit 10. So if you look at this graph, what is a range going to be? Well, let's see. Right here is the lowest point, which is 1, comma, negative 0.75. And am I going to look at the x value or the y value? I'm going to look at the y value because that's where I look for the range. The range is where do the y's exist? The y values exist. And meanwhile, I'm going to extend this a little bit. And so eventually at some point, I'm going to hit a y value that is going to be 10 comma something. And so how do I find this 10 comma something? Well, do my side notes. Well, how do I find the y value when x is equal to 10? Well, you just plug in 10 into the original equation. So c at 10 is equal to 0.75 bracket 10 squared minus 1.5, 10. So that's equal to 0.75 times 100 minus 15. So 75 minus 15. C at 10 is equal to 60. Okay, so that means those are my help me inform. Those are going to help me inform my range. So I already used the highlighter to describe my optimal value, so we'll stick to that color. And then this is where my range ends. So I'm going to write my range down. So range of this cost function is equal to y elements are real such that you have range y values from negative 0.75 to 60 and all including. Okay, how should the domain 0 to x from 0 to 10 be further restricted so that the inverse is a function? So I kind of already dealt with that. No, I didn't. So if you look at the blue graph, how would I change it so that this graph will work out? So it says, how should the domain 0 to x to 10 be further restricted so that the inverse is a function? So notice that I have this part and along with this curve. And so when I take the inverse, it's not this inverse is not going to be a function because of this part right here, right? And so I will need to cut it off so that I have the inverse to be a function. And how do I do that? So easiest thing will be is to get rid of the part from 0 to 1. So I'm only looking at this part. Why? Well, this one, it looks like the bigger piece, so get rid of the smaller piece, right? And so my domain is going to be x elements are real such that, well, I'm not going to include the values from 0 to 1 because that's going to make that inverse function not a function. And so I'm going to say that 1 to 10 are the values of what I want for domain. So if I have it like that, then the inverse is a function, so i.e. that it passes the vertical line test. Write the model for the item sold as a function of cost. Okay, so what does that mean? Break it down. Write down the model. That means you need to find the equation for the item sold. Okay, so that means I am trying to get this by itself, which means I'm really making that the output and as a function of cost. So that is going to be the input. All right, so I have my original equation, which is c at x is equal to 0.75 x minus 1 squared minus 0.75. The reason I'm using the vertex form is because my x appears only once. If I took the standard form, the x appears twice, so it's going to be hard to get the output by itself. And so it looks like I want the item sold, which is this, I want that by itself. So I'm going to write, okay, well first I use vertex form, as x appears once. And second, I want to isolate the output x. All right. So I want to work towards getting the x by itself, doing BEDMAS backwards. So I'm going to write c at x as just c. I want to move that negative 0.75 over, so it's going to become positive 0.75 bracket x minus 1 squared. By following BEDMAS backwards, I usually always put the brackets here so I don't make any mistakes. So by BEDMAS backwards, I am going to not touch the brackets, and I want to instead divide both sides by 0.75. Notice I put the brackets on the binomial, so I'm not tempted to cancel anything out when it's not supposed to be. So c plus 0.75 divided by 0.75 is equal to bracket x minus 1 squared. Okay, I want to get x by itself, but I need to get rid of the square roots, the squared, by using square roots. And if we do that, we always get the plus and minus version, but we always have items that are positive, and so it's going to make sense to just take the positive version. And so we have x minus 1 is equal to c plus 0.75 divided by 0.75, and all of that square rooted. And we have one more step. I want to get x by itself, add 1 to both sides. X is equal to square root of c plus 0.75 divided by 0.75 plus 1. And that's about it. Let's see. So x represents items sold. And that's what the question wanted us to write. I'm just going to write that we wanted the positive version when we square rooted because items are positive. So I want to just write that in our notes. So items are positive. You're not going to have negative number of items.